Okay guys, so today we're doing geometric proofs. If you missed the lesson, here's the video to go with those notes. So we were working on algebraic proofs with just solving for x or solving for y, but now we're throwing in geometry. So with line segments and angles and those kinds of things. So if you don't have your reference sheet out yet, you should probably get that out in order to do these notes. So the proof of the transitive property of congruence. So we always, our first reason to go with the statement is the given. So JK is congruent to MN and MN is congruent to PQ because that is given to us in the top part of this question. JK is equal to MN and MN is equal to PQ if you're looking at your reference sheet because of the definition of congruent. So basically anything that is congruent to another thing is also equal to that other thing. The third statement, we can, think about, okay, these MNs are the same, so I could rewrite it as JK equals PQ, which is the transitive property of equality. And then we can use the definition of congruence to get line segment JK is congruent to PQ. Basically, you are starting with your given statement here, and you want to get down to your proof somehow or another. Okay, so given line segment JK is congruent to SH and line segment SH is congruent to line segment MN. So the first statement is a given. The second statement is also a given. Sometimes we separate these for you just because there might be a lot of information and it's too much to put on the first line. So then this is very similar to the other one. We can use the transitive property and set JK congruent to MN by using the transitive property. Basically, all you are doing is looking at your sheet, getting the reasons for why we can do this, and then writing those reasons down along with the statements if you need to. K is between J and L, JK is 6, and KL is 10. So my first statement is a given. K is between J and L. My second statement, JK is 6 and KL is 10, is also a given. Now, if you don't know what postulate, definition, theorem to use here, you kind of need to put 2 and 2 together and say, okay, this is a line segment up here. So look for a definition or a theorem or a postulate that talks about segments or line segments. And the answer to that is the segment addition postulate. And we can write this down here because a piece plus a piece equals a whole. Then my next step is I'm taking 6, I'm plugging it in, I'm taking 10, I'm plugging it in. And that is because of the substitution property. My last one would be to add 6 and 10 together to get 16, which is simplify. Whenever you are adding, subtracting, multiplying, or dividing on the same side, you can call it simplify. M is the midpoint of line segment AB, and AM equals 10, so we're proving MB equals 10. So M is the midpoint of AB, that is a given. AM equals 10 is also a given. If you're stuck here, you can look, okay, definition of a midpoint. Find that on your reference sheet and figure out that, okay, if something is the midpoint of something, this piece is congruent to this piece. So we can write that down. AM is congruent to MB. Then we can switch it to AM equals MB because anything that is congruent to each other is also equal to each other. And that is the definition of congruence. My last, or you can have a couple steps here. So I know that AM is 10, so I can plug in 10 for AM. And I'd get 10 equals MB. And that is because of the substitution property. Now, this answer does not look like what my proof says. So I need to take it one step further and say MB equals 10 by the symmetric property. Now, you could not write this, and you could just go straight to MB equals 10 and use the substitution property for that reason. That's fine, and then you don't need your 6 for the statements or the reasons. You can do that, but just know that if you leave your answer like this, right, you do not have it correct then, because it does not match your proof statement up here. Line segment BC is congruent to CD, AD equals 8, BC equals 8. So my first part of my given is not written, so I need to go ahead and do that. BC is congruent to CD, that's a given. The next part is also a given. So then you might be like, oh, I'm kind of stuck here. What do I need to do? This is substitution. So that means I need to do something here with substituting something else in. I know that I have AD in my proof, so I need to keep this AD. What can I do in order to keep the AD? I need to plug BC in for 8. So AD equals BC, and that is, the substitution property. Next, definition of congruent. So basically, if something equals another something, we can say that they are congruent to each other because of the definition of congruence. Then look at I have BC here and I have BC here. But then the things that I need for my proof statement are here and here. So I can use the transitive property to write line segment AD is congruent to line segment CD. Measure of angle 1 is equals 75. Measure of angle 2 is 105. That is a given. That's in our original problem at the top. Then I have the addition property of equality because I am adding these two together here. Okay? I'm adding the measure of angle 2 to both sides. Then I am substituting 105 in here for the measure of angle 2. So that's substitution property. My next one would be to add 75 plus 105, which is simplify. And then, because the measure of angle 1 plus the measure of angle 2 equals 180, by the definition of supplementary, my angle 1 and angle 2 are supplementary. These ones are a little bit more tricky for you guys, but the given is angle 5 is congruent to angle 2. Then we have, so angle 5 is congruent to angle 2. Then angle 2 is congruent to angle 4. Why is that? It is because that they are vertical angles, so it's a vertical angle theorem. Then we use the transitive, which means that we need to cancel or take away something here, which would be the angle 2, to get angle 5 is congruent to angle 4. Then we need to throw an 8 somewhere in there, so we have an angle 5. So we also need to use angle 5 here so that I can somehow use the transitive property. And we can say that angle 5 is congruent to angle 8, which it is because they are vertical angles. And then we can get rid of these angle 5s here and say that angle 8 is congruent to angle 4 because of the transitive property. Next, this is going to be the same thing. With angles, we're always going to use the transitive property or the vertical angle theorem, and then later on we're going to add some more to that, but not in this chapter. So, angle 1 is congruent to angle 4, and that is because it is a given. Then we need to do something with my vertical angles here, whether I use the 2 and the 4 or the 1 and the 3. I think I use the 2 and the 4 first so that I can use the transitive property later. So angle 4 is congruent to angle 2, and that is because of the vertical angle theorem. So angle 1 is congruent to angle 4. Angle 4 is congruent to angle 2. I have these angle 4s here, so I could say that angle 1 is also congruent to angle 2. Then we need to end up with 2 and 3. So somehow I need to add this 2 in here. I can do angle 1 is congruent to angle 3 because of the vertical angle theorem. And then I can use transitive again to say that angle 2 is congruent to angle 3. The last one, so angle 1 is congruent to angle 3, and that is because it's a given. If I have angle 3 and angle 6, those two angles are vertical angles, so they're congruent because of the vertical angle theorem. Then I'm using transitive again, so that means that I'm going to rewrite angle 1 is congruent to angle 6. Then angle 1 is congruent to angle 4, and that is because of the vertical angle theorem. And then angle 6 would then be, whoops, I didn't want to do that. Angle 6 would then be congruent to angle 4 because of the transitive property. There's one more PowerPoint. I'm working on the video right now, so if you are stuck, go on and look at that next video as well, and then do your homework. Make sure you turn in all of your missing work, guys. The quarter ends very soon.